On This Week in Enterprise Tech, it's the best of TWiET in 2016.
Netcasts you love.
From people you trust.
This is TWiET.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CACHEFLY.com.
This is TWiET, This Week in Enterprise Tech, episode 220, recorded December 19, 2016 for December 30th, 2016. The best of 2016. Welcome to TWiET, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballecer, the digital Jesuit, your guide to all things in the enterprise. And I'm actually not joined by my regular cast of characters this week because it's a special episode. We comb through the entire inventory of TWiET in the year, and we found the individual segments, the interviews, the bits of information that you needed to know for all your enterprise goodness. So without further ado, here's the best of TWiET in 2016. Folks, we welcome back to the show, this is my favorite part of every episode, Mr. Karl AUERBACH of InterWorking Labs. Karl, first of all, I love this new setup. What is this stuff that we see behind you? This looks like a geek maker paradise.
No, we're just one of the few offices around where with a weapon of mass destruction in the background. That's a prop from a play I worked on. You know, and we have the stuff to properly power equipment, some jumper cables over there, and to, you know, make sure equipment responds properly. You know, we break things, or I break things. And that's actually the theme of today's program is people don't break things often enough. People test stuff in the lab. They put it out on the net maybe for a while under friendly conditions, and then they start selling it. And eventually somebody discovers, oops, you know, it would be really bad, for example, if Boeing simply put out his brand new airliner, took it up on a sunny afternoon and flew it and said, great, let's put it into service. But unfortunately on the internet with a lot of products, that's what people do.
Karl, let's talk about that, because that's actually something that Chibert has brought up before. That gear manufacturers love to talk about their specs. They love to talk about their throughput and every special piece of circuitry that they've added to the product that makes it better than every other manufacturer. But it's very difficult to find a manufacturer who will give you honest data on A, have you tested this properly? Have you thrown every exploit against it to make sure that it's not going to get through? And B, will this actually work in the real world? I mean, we all know the phenomenon of real-world performance not meeting what the technical specs say it will. Why is it? Is it just so difficult to test for exploits and real-world experience?
Well, I don't deal in the word of exploits. We deal more in the area of just people make mistakes writing code, leaving the word unsigned off of the front of integer. That's a real common one in protocol implementations. We've seen that in voting machines where they get to 32,767 votes and then start counting backwards. No surprise to me, but it was to the people who made it. There's an old medical machine, a Therac something 25, that was basically a X-ray kind of machine. And it had a numeric keypad, and the operators would just go, you know, when they were testing, it go 1, 2, 3, 4, 5, put in the numbers. And after putting and it worked fine. Then they went out in the field, and the operators got really good, and they do 1, 2, 3, 4, 5. And nobody ever tested N key rollover. So eventually, somebody got X-rayed to death. They got basically microwaved by this machine because of a software flaw. That's really hard to test for, because people aren't expecting that. Also, if we go to the internet, a lot of the protocols are not well defined or incomplete. Like, for example, the IETF mailing list has been filled this week about problems with IP fragmentation. IP fragmentation is an old ancient topic. Yet there are so many variations of the way packets can be fragmented and reassembled that virtually nobody's code has gone through every possible condition. And I have not yet found a piece of code that will survive all the IP fragmentation patterns I can throw at it. So we have a lot of gear that's out there in the field that's working fine today, but may fail sometime in the future when presented with a new peer. And who are they going to blame? The new peer or the old equipment? Probably the new piece of equipment.
The last time you were here, you were talking about the DARPA robots, the robot challenge, which is fantastic. Everyone has watched hours of video of that challenge. This time, though, we're calling upon your experience of bringing equipment in the real world to show off something that you have created. Tell me about the KMax.
Okay, the KMax is not really a new idea. We used to have these things called TCP/IP bake-offs, where we would get a bunch of people together, bring our code, and just see what we could break with each other's code. They usually went on for 3 or 4 days. It was a lot of fun. Pillsbury got upset when we used the word bake-off, so we had to find another name for it. And John Postel was participating in these things, and he said, you know, we need a box that does things wrong, intentionally wrong. So he called it a flakeway, and it's written up in one of the RFCs from way back when about TCP and testing. Well, several years ago, I did a company to do a high-quality video back on the network back in '95. And if you use some of the video distribution protocols, RTP, RTCP, for example, they are really hard to test because there's a lot of very subtle timing things that can happen. And also, if you're trying to do synchronization of voice and on video, timing is all critical. And what happens if one packet arrives first? What happens if something gets out of order? We had no gear to test that. So I decided to go out and build one of these things. So over the last 10, 15 years, we've been building a series of products called Maxwell's after James Clerk Maxwell's idea of a thought experiment of a demon that could cause a hot area to get hotter and a cold area to get colder, a thing called Maxwell's demon. Well, we took that idea and put it into a little box called Maxwell. We had products out there for a couple of years doing these sort of things. And our newest generation is a whole brand new implementation, which we call KMax, for kernelized Maxwell. Some people think the K stands for Karl, but it's really kernelized. The first version of that is this little guy here. So I actually got something else on the screen there. Anyway, this is the first little guy. It's the entry-level version of the product there to test the ideas out, to work out the bugs and flaws, and then eventually we'll expand it into larger platforms. What it does is essentially I was going to show it to you here. The back panel is it's a bridge between two of the ports.
Little higher.
Okay.
There we go.
Yay! There's a port for control, and there's 2 ports which we're bridging data between. We can do more ports, but this one only has 3. The idea is that we get it between those 2 ports at layer 2, and we do bad stuff to the traffic. Intentionally bad stuff, controlled bad stuff, sometimes even statefully bad stuff. And that bad stuff can include everything from simple things, what we call standard impairments, dropping things, delaying things, resequencing things, rate limiting, corrupting stuff, all those sort of normal things. We're also, in the future, going to be doing packet rewriting, smart rewriting of header fields in packets. We've got our larger products, which we will be importing into this later on. Our protocol testing, where we will do things like turning a TCP 3-way handshake into a 4-way handshake. That surprises a lot of implementations, perfectly legit. We will coerce things like the initial sequence number to be something that's right around where the high order bit flips, which is where a lot of implementation errors are found in code, or where we've taken all the things which our implementation experience since the late 60s has shown that people make mistakes, and we put in tests for those. Right now, this box is the beginning of a whole new line of that. It has what is basically what we call the standard impairments. And I've got a screen up here I can show you.
Yeah, let's go ahead and demo this. Let's show them what it looks like.
Yeah, let me figure out how to share a screen here. Not that great with Skype. There we go, share screen. And I'll take that screen. Okay, can you see it yet?
It should pop up in just a second. And
come on, Skype.
Come on, Skype, do your thing. There we go.
Oh, yay.
So this is the actual interface.
This is one of the interfaces. The this is one scenario. We have many, many scenarios. This is a 5-band scenario. We have ones that are single band. We have ones that are based on templates where you can say, I'd like something that looks like a low Earth orbit satellite or a high Earth orbit geosync satellite or a low Earth orbit geosync satellite, if you can figure out such a thing. Or a radio handoff where you're fading out from one base and moving into another. We have scenarios for all that. But this is a basic one. The idea is, you got an interface on one side. You got another Can you see my mouse?
Yeah.
An interface on the other side. And what we go is the packet comes in one interface. It goes through a classifier. I'm going to move to the other side here. It's closer to me. And we can classify that according to some filter expression. Here's one that's basically picking UDP packets that are shorter than 255 bytes. And classifying it into one of these bands. What I've got set up here now is a packet that arrives on this interface, goes in. If it's meets the filter expression, which is a small UDP packet, it goes into what we're calling band 1 here. If it doesn't meet any expression, it goes into the default band, which is this top level thing here. And we've got these little meters here. They're telling us roughly how many packets are going through this right now. There's a VoIP call flowing over this right now. And that's some graphs. You can see the packets going over that. Now, what we can do is we've got various things we can do to this. We can delay it, and we can put in all kinds of interesting delay patterns. We can put in a constant delay. We can put in a delay that's varying according to, say, a Gaussian distribution. We can put in, we can vary the parameters of the Gaussian distribution, or we can vary the delay based on a time pattern. I'll show you that in a minute. We can do all kinds of things there. And let me just get out of that.
So basically everything from drop packets to delay to jitter, you can simulate that.
Yeah, in delay, jitter is a form of delay. It's a varying delay. And in this case, I can set up a thing where I'm basically delaying it over a Gaussian distribution. I can set the mean and the standard deviation of that distribution. I can also pick how many packets do I want to have subjected to that delay, all of them, none of them, some collection of that. I can also add a fixed delay to that, so I can bias the Gaussian distribution off. So I can have like 150 millisecond baseline, and then I can put the bell curve off to the right of that. And then, of course, I can vary that over time. For example, one of the things that's really kind of fun to do with TCP is I can create a sawtooth wave where I have a raw delay of, say, 0 milliseconds, and then over a period, say, of 60 seconds or something, I will bring that up to, say, 500 milliseconds, just a linear, and then just drop it back down to 0, and then begin it all over again. That seriously exercises the congestion detection and recovery algorithms in TCP, many of which do not do very well in those scenarios. We've seen one company that was selling basically web servers that they backed off beautifully, but their recovery algorithms didn't recover.
Right.
So there's all kinds of fun things you can do with that. Now, what I've got running here is I've got a simple drop pattern running on this VoIP call. And I've set up a little time-based variation here so that over a curve, I have a baseline of a few seconds. I think it's 3 seconds. Then I go from a drop level of 0% up to a pretty serious 80% packet drop. I hold that for a few seconds. I think 4 seconds. That's my hang time here. Then drop it back down to 0. And my call is going through that. And you can hear the effects of that. I can place a call and tune you in, and you can hear me talking through that. What'll happen is while we are on this part of the curve, where if you can see my mouse, the call will be pretty good, and it's going to get seriously bad. Then it'll recover again. It'll just keep going through that.
All right, let's
do that.
Yeah.
Let me do that now. I have to fuddle with the soundboard here. I'm going to turn off my main mic, and I'm going to turn on the mic for the phone. So here we go.
And now you should be hearing through the VoIP calls. You should be getting bad. I'm probably
Everyone knows that sound.
Okay.
Yeah.
And now it should be good again, and it's going to get bad again. And we're just recycling.
Oh, that's phenomenal. I love this.
Real microphone.
That is a great testing tool. I mean, and actually, the interesting thing is your VoIP call was okay until you got above about 50% packet loss. At 50% packet loss, we could no longer make you out.
I wanted something that was really overt for this call.
Yeah.
When
you think of an enterprise deployment of Active Directory, what are the points of failure? What are the things that are most likely to be exploited, that are most likely to lead to breach, that most likely are overlooked as vectors?
So if we talk about that, let's actually talk about what the goal of the attacker is. Okay. So we mentioned earlier that attacks are currently in progress. It's not just a one-time event. I mean, this is a campaign that's going on, and attackers actually have a progress, a set of steps that they're trying to go through. What they're looking for is leverage. What they're first looking for is a way in, and once they find a way in, whether it's through a third-party system, whether it's through exploiting an email on somebody's laptop, that's not the goal that they have. That's just their first footstep. That's their lily pad. Where are they trying to go? They're trying to go into a place where they can get access to the rest of the network. And they're looking for leverage. And there's a few systems in every organization that actually have more leverage than anything else. And those are the systems that are used to run the rest of the enterprise. If you have access to any one system in the network, where do you want to go? You want to go to that one device that has all the keys to the kingdom, that's authorized to talk to every other system in the organization, and by the way, is the one that can actually grant you access to go wherever you want to go.
Right. You want the device that could escalate privileges for everything. And
absolutely.
If you own AD, you own the network.
Absolutely.
So even a user credential with an AD, as one of our online folks was commenting, it's not going directly at the AD system. It's going for a credential that AD has written, signed, authorized, and said, you're an enterprise admin.
Yeah, and actually I think that might be the frustrating part for a lot of IT admins, which is they don't necessarily have to own AD. They just have to own a user who has enough privileges in AD to be able to escalate what they need.
Absolutely.
Which, how do you protect against that?
You know, why don't we do something interesting? Let's do something that's really, really stupid, but actually probably intriguing at the same time. Then could you pull that URL up? Because it's kind of funny. Just for the sake of this show, while we're here live and probably over the next couple of days, we put a running production forest outside a firewall with no perimeter security whatsoever on the internet.
Oh, yeah, I used to do that for fun. That would be like bringing up a Windows XP machine and putting it in an open IP.
Look, a honeypot, right?
Yeah.
I mean, so yeah, we figured we could test the thesis here and actually build a software-defined perimeter, trusted hardware, all this fancy stuff. But the reality is, how do you even create a system that is designed to protect those credentials? First off, you have to trust the system. And one of the fundamental problems we've had is that there's no ability, first off, to buy clean source hardware and software in most cases. How do you even know the supply chain is secure? Beyond that, how do you know that nobody's rootkitted? How do you prove the software running on your system is yours and nobody else's? Okay. Some of the fundamental challenges today.
Take me through it.
Oh, Dan should do this. He's this.
Well, first, let's take a look at this. So what we've actually done, as Doug mentioned, is something a little crazy. And this really gets to the point of what you want to be able to protect. So if we pull back, part of the real protection strategy here is compartmentalization. How can you create portions of your network that can actually start to defend themselves and be secure from attack? And to prove that, what we've actually done is, as Doug mentioned, we put a server out there on the internet. It's directly on the internet, no firewall, directly attached to our core hosting provider. And on that, we're hosting a web service. That web service is protected by a system, but there's other applications on there. One of those is this Active Directory forest. And what we've done is provide a way that we can provide this protection encapsulated in a way that's easy to use, where it's easy to know that it was hardened and you got the security policies right every single time. And Active Directory is just one example of the types of systems you want to be able to protect like this. So as we start looking at what we're doing here, let's actually take a closer look at what it really means to protect something like Active Directory. If we're talking about privilege escalation, it means going past just looking at the protocol itself. So, Doug, who really owns your Active Directory server?
Well, I mean, of course, Dan, there's the guy assigned to be the domain admin. You expect this person to be a owner of it. But there's also anyone with physical access to your server has the ability to rapidly become a domain admin. The person who manages the hypervisor, if you're running in a virtualized environment, is a domain admin. The person who administers the backups, this one cracks me up, because when you back up Active Directory, the low-level backup admin who does fancy tape rotation has the ability to look through that and become a domain admin. The person with access to the IPMI ILO out-of-band management network is a domain admin. As we look at each of these, there are discrete, published, well-documented attacks for each one of these that allows somebody to become the overall enterprise admin. My favorite, though, is the very last one. If I can get you to open an email that I want you to open from an admin workstation, or go to the URL and web page I want you to go to from an admin workstation, I have the ability to become a domain admin as well. So when we think about how do we secure this application, yeah, there's good trusted hardware, there's the right perimeters, there's a human element to this. And it's how do we build a security system that keeps the admin from doing the stupid admin trick, the stupid human trick we always do of, maybe I should just RDP in from my desktop because it's easy, because I'm smart, I haven't opened the email from my Nigerian uncle, therefore I'm gonna go RDP in and open this thing up and just add one user account, it's no big deal. Or let me forget to log in out of my domain admin account and log in to administer that one server that says it's overheating right now. Why is it overheating? Because the bad guy corrupted the log file, put in a, faked the temperature sensor warning so that I could jump right into it and check it out while he's getting ready to dump the lsas.exe file. Right?
Well, so let me jump in here. You've been giving me a lot of nightmare scenarios.
Oh, good. Those are fun.
Those are fun.
Dan's great at those.
Yeah, when Dan was talking about proper policy, it brings up the question of, well, what's improper policy? You brought up a couple of things, which are, well, are you accounting for people who have physical access to your server? Are you accounting for people who may have escalated privileges inside your system who then get owned? But what would be proper policy to protect you against those circumstances?
So let's actually take a look at a scenario like Active Directory.
Okay.
So there's something that's a little tough about security, and that is what the real answer is. Actual security is like losing weight. You get it from diet and exercise. It's hard to do. And there's no technology that actually solves all of these problems. If we're talking about Active Directory, there was actually a guide published by Microsoft. It was just updated at the end of last year. It's about 300 pages. 288 pages, I think, at last count, is actually how you secure your Active Directory. The problem isn't actually in the application or the protocol. It's how you deploy it. How do you guarantee that the system itself is safe? And how do you start to separate privilege in the system? And it's not just about how do you make yourself immune to an attack on a system. It's limiting the scope. This is really the most important thing about trying to make more secure systems, is not to say this one thing will solve my problem. It's being able to say, I know for a fact that I can put something out there. It may or may not be compromised, but I can at least have the confidence that if they crack that system, they're not going to be able to go to the next system. And that's really the methodology for actually protecting something like AD. So one of the things that we're doing is looking at, if AD is the problem, if pass the hash, pass the ticket, privilege escalation is really part of the problem, how do you start to compartmentalize it? How do you start to limit the scope of what an attacker can get access to? And that's really the best way to protect something like Active Directory. And part of what Skyport is doing is providing a way of complying with a large portion of those 288 pages of that hardening guide, establishing and maintaining clean source, and also helping you easily and quickly deploy an Active Directory implementation where you've separated privilege. You can separate things like production domains from core admin domains, so that that golden ticket, that domain admin ticket, is something that can't be exfiltrated. It's something that can't be stolen. And this is really the point of how we start to come to the grips with these systems. We harden the overall environment, we segment it, and we separate privilege. And that's largely a part of what we're bringing to bear.
Let's go ahead and jump to the No Jitter booth at Enterprise Connect 2016, where I had a chance to interview a very interesting man from Cisco. I'm Father Robert Ballecer, the digital Jesuit, host of This Week in Enterprise Tech on the TWiET TV network. I'm here in Orlando, Florida for Enterprise Connect 2016, and I've got a special treat for you. I'm sitting next to Mr. Jonathan Rosenberg. He is the Vice President and the CTO of the Collaborations Technology Group at Cisco.
That's right.
Jonathan, thank you very much for joining us.
My pleasure. Thank you for having me.
Now, we don't have to do that part of the interview where you introduce your company. I'm pretty sure everyone knows.
No, we make toilet paper. You've probably seen our trucks driving around. Food supply and services. No, the other one, the one with the C.
One, yes,
with the networking.
But it's been a very surprising week for Cisco. You've had some announcements that have people kind of nodding their heads. Can you talk about them?
I would love to talk about them. So the first announcement, which really isn't a huge surprise, but we have announced the general availability now in the US of our new Spark service that's calling, messaging, and meeting. The calling part available in the US, the rest of it available everywhere Cisco Spark has been available. This is a huge milestone for us. We announced the capabilities in November, and now, just a few short months later, we're ready to sell. So that's probably the big announcement. The second announcement, which I think really is a surprise, probably the big surprise for the show for us, was the developer fund. So, Rowan likes to say we put our money where our mouth is, and he means it. We've put aside $150 million. That's not, Padre, that's not chump change. No, it's not. That's a lot. It wasn't like he just took out his wallet and put a few 20s down. That's real money for developers that build on top of the Spark platform. And we think this is going to obviously help drive a lot of innovation and really proves how committed we are to APIs, to developers. We had a lot of other announcements too. The one other I would mention, I guess, is that we announced this thing called Presenter Track. It's like super, super cool. And it's a telepresence feature that allows someone to stand at the front of the room and be presenting. And literally, it's like there's a cameraman that's following the person automatically around, but it's completely done in software. And it is amazing and allows you this great remote experience when you have someone like presenting in the front of a room.
One of the things I do want to go back to is the developer fund, because I think you're right. That was a surprise.
Yep.
And it would be easy to say, oh, it's sort of a PR stunt.
Yeah.
It's just a toss away. But $150 million is not a toss away.
No, it isn't a toss away. We had to fight for that money. I mean,
tell me about the strategy there. What is the hopes for that $150 million? What do you want it to develop, or do you even know?
Well, I think we're going to see, right? But the core idea we want to do is that we really committed to an open platform, and that's all just words. It's just words, Roger, unless there's actually people who are building applications on top of this platform. And when we look at what we think is going to make communications and collaboration successful in this new world order, it's about an ecosystem, right? And that doesn't come easy. So for us to really make this transition from where Cisco's traditionally been to someone that people like, there's tons and tons and tons of apps on it, we need to put some money to make that happen, and so that's what this is about. That's the strategy. Build the ecosystem that drives value into our platform. Simple as that.
All right, Jonathan, I got to ask if you could shine some light on this.
Yeah.
There has been a lot of upheaval in this industry over the last year. There's been this huge move, this almost desperate rush for companies to offer all of their solutions to be as a service.
Yep.
That's number one. And two, to be equally good, on-prem, off-prem, hybrid. Is that the right way to go?
Yeah. So I actually would like to challenge that traditional thing. Yeah. Is you hear that from lots of vendors, because that's what customers ask for. What they say is, I would like to be able to buy it in the cloud or buy it on the prem, and it's exactly the same thing, right? This way, it's just my choice of consumption model. That sounds good, right? It sounds good. But what it misses is that cloud, in many ways, is fundamentally different. And it provides a bunch of properties that are only possible in the cloud. And so if you build your software in a way that allows it to be the same on-prem as the same in the cloud, then you're by definition missing out on the things that are uniquely cloud. And a lot of these are technical, but they result in real benefits for the customer. Let me give you, Padre, my favorite example.
Please.
My favorite example is A/B testing. So A/B testing is a very common practice for cloud providers, where if they want to know what's the thing that drives the best engagement and user experience, they try something, they give 5% of users option A, they give another 5% option B, and the classic example on the web is like, what color should the button be to drive click-through rates? But in collaboration, we worry about things like, how do we make sure users understand how to engage with the feature? Why aren't they completing the call transfer flow? How come they're, do they try and send the message and delete them a lot? Like, what's wrong with that? So we can actually A/B test user experience, things like this, to actually make the product better in the hands of users. You actually have to build a bunch of stuff in your software to enable that. Different builds, different analytics and pipeline. You can't do that on the premise. Cannot. It's like fundamentally infeasible. So if you have a piece of software that's the same in both places, how are you taking advantage of that? My second thing that's big on this is the ability to push new software into production on the servers multiple times a day, to constantly be iterated. And continuous delivery is the secret to great user experience, to quality, to innovation. It's the secret that's been making all these consumer players move really fast and produce great products for users. Right. Well, let me tell you, you can't do continuous delivery on-prem. And more importantly, if you want to do continuous delivery in the cloud, you have to build different software for it. Why? Well, you got to upgrade the thing all the time. So like, can you have an outage when you upgrade? No. Most premise software, you have to have a maintenance window, and upgrades is this whole like weekend-long affair for the IT guy. But you can't have that. So when we built Cisco Spark for continuous delivery, we upgrade it all the time, and it's completely hitless.
The traditional logic is, well, yeah, of course, I want my solution to be flexible.
Yeah, it sounds great.
But the way that you describe it, it sounds more, well, you're getting the worst of both worlds.
Exactly.
You're getting the
least
weakness
common
of premise
denominator.
and cloud.
You're getting the least common denominator. And we don't believe in least common denominator. We want awesome.
We want awesome.
Exactly.
Speaking of wanting awesome, I'm going to ask you to look into your crystal ball here. Look forward a year. Enterprise Connect 2017, maybe in a couple of years. Enterprise Connect 2020.
Okay.
What are the trends that you're starting to see right now that you think are going to shape who is going to be on this floor?
Great question. So a bunch of trends. We already talked about one of them, move to cloud, not new. I think the pace is picking up. It's accelerating. So I think in 2020, everyone's going to be here, and that's like, you're not even going to talk about cloud anymore. That's like not going to be the big thing. That's like, yeah, of course it's a cloud solution. So that's one thing that's going to be much different. The second thing I think is different is we're seeing another transition, which is how people think about this market. Like traditionally, it's been very segmented. You've had video conferencing vendors, you have audio conferencing vendors, you have UC vendors, you have phone vendors, and there's like these little silos of products that the enterprise actually traditionally bought sort of best in breed and then stitched the whole thing together, and has started to notice that you don't get the optimal user experience when you do that. So the trend we're seeing, especially as people move to the cloud, is people are moving towards a more integrated experience. And so this is what we're doing with Cisco Spark. It's designed so that you can't even, like, calling, messaging, and meeting is part of what it does, but like we want to get it to the point where you can't even tell where one of those ends and the other begins. It's just one thing, you get Spark. And others are doing some of this too. We think we're ahead. But you know, Microsoft is doing this, they're offering a broad portfolio. You're seeing even the guys who just used to do UC, now they're picking up messaging companies and meeting companies. Like Fuse is another good example of that. They're trying to build a thing. Now they're sort of trying to cobble it together. We've actually done it from scratch. So I think the trend you'll see is these micro niche providers have faded away, and it's all about who can provide a collaboration solution that makes it easy for people to work. That's what you actually want to buy, not I want to buy a video telepresence endpoint.
Would it be fair to say that you expect at some point in the near future, you'll no longer be able to tell the difference between your unified communication solution and your productivity suite and your network suite and your network applications, but the providers that survive will be the ones that give you sort of that all-in-one?
I think so. That's exactly what I'm saying.
We have been speaking with Jonathan Rosenberg. He is the CTO and the Collaboration Technology Group at Cisco. Thank you so very much for spending your time with us. Thank you for sharing these insights. I think be very valuable to our listeners. Now, if they wanted to find out more about what you do with the Collaboration Group, if they want to find out more about what you presented here at Cisco, where can they go?
Well, for Cisco Spark, guess where you go? www.ciscospark.com, and of course, cisco.com with a C, I-S-C-O, for everything else.
So, one of the things is we want to become experts on anything related to voice, any kind of fraud that's perpetrated on the voice. And though our focus has largely been on the enterprise side of things, we thought about how do we also help individual consumers like you and I, right? And so one of the things that we started looking at is what are the kinds of scams that individuals like you and I get constantly bombarded with. And given that it was tax season, right, starting January 1, we did a whole bunch of research on trying to see, out of all the robocalls that people get, how much of that is tax scam, and what can we learn from that tax scam. And it's really, really interesting what we found. What we did first in order to fundamentally see what kind of calls individuals like you and I get is similar to the Canary system that you just advertised about. We have a phone honeypot that we set. We have the world's largest phone honeypot. We call it our phonypot. Essentially, it's a bunch of phone numbers that no one is supposed to call. And we've set that up such that if it gets a call, invariably that's a scam call. And then we started collecting those scam calls and start classifying them. So that phone honeypot itself, we have about 250,000 fake phone numbers. So that makes it one of the world's, I mean, it's one of the largest honeypots. And we get about 90,000 calls, about 90,000 phone numbers calling our system every single month. And that amounts to about 500,000 fraudulent calls coming into that phone honeypot. And based on that is what we did our entire analysis on the IRS scam.
The last time you were on and you were talking about people hitting phone trees, you had some very interesting software that was showing us how you could identify what regular activity looks like. And a regular activity would be a number calling maybe this number and then this number. But then you have these phone scams. And what it looks like is you have one number that suddenly is dialing every number that it possibly can. And it, when you put it into one of those big data analytics screens, it actually looks very obvious. Not so obvious when you're actually experiencing it. Take a step back now and explain to our audience what are the common tax fraud scams that you would get over the phone. How are they using that phone call to get information about me?
Yeah, so fundamentally, there seems to be three kinds of scams related to tax. The first one is essentially the most scary. It's a threatening call that comes to you and says, you owe so much in back taxes, and we need you to pay that amount. Otherwise, you're going to have law enforcement show up at your doorstep and arrest you. So, you know, that amount ranges, right? It's anywhere between $1,500 to $5,000. But they say that's what you owe the IRS. They call themselves, you know, the Federal Investigation Bureau for the IRS. And so they call in, threaten you with warrants and arrest, and try to steal money from you. The second kind is, being able to help you with your back taxes and the payment of it. That's the second kind of scam. And then the third is, tax companies that are trying to get you tax relief. So these are the three big categories. But the one that's most nefarious and most troublesome are the ones that threaten you for the fact that you owe the IRS taxes.
Right. And unfortunately, we've all heard those stories of someone who sends in a check for $4,500 thinking that he or she is putting themselves in the clear. And of course, they've just given that money away and they still owe money to the IRS, which that's special. That's special. Yeah. Vijay, it strikes me that this specific work that you've done with tax fraud is a great extension of what you do every day at Pindrop, which is, and you told me this last time, your primary job is to think like a criminal. You try to think like the people who might be defrauding an organization. And so you put yourself into their shoes. You say, well, what do you have that's valuable? What might they want to go after? How might they go after it? And that's the first step. Before any of the technology kicks in, before you track any of the numbers, before you look at any of the big data analytics, you need to know what is it that I can steal from this company and how, if I were actually trying to do it, how would I go about doing that? So every time you bring up a use case, and let's use tax season as this, how do you do it? How do you sit down with a bunch of people? Do you have a couple of former fraudsters on the payroll who might be able to help you with this? How do I put myself into the mind of the bad guy?
Yeah, we did it really simply, right? So what these guys were doing is calling our phone honeypot system. So it's a massive set of phone numbers that are getting these phone calls, and fundamentally determining that some calls of them are for IRS scam, right? Because we collect those calls, we transcribe those calls, and then cluster them, and so we know a set of those calls are coming for the IRS scam. And so what we ended up doing is we took one of the phone numbers that got called, and we obviously got the phone number that called us, and then we called them back with one of our researchers, and we spoofed the phone number that they called. And the interesting thing is that was important because if we just used any generic number to call them back, they actually didn't pick up the phone, right? Like we got, a very, very strange message which said this phone number was disconnected and things like that. But when we called them back with one of the phone numbers that they called in our honeypot, evidently they have a list of their own, right? And so they have a list of people that they're trying to call, and one of them happened to be in our honeypot. So we use that phone number, call them back. and actually engaged with the fraudster. So we did step-by-step instructions on what they asked us to do. And so we fundamentally have that entire thing transcribed. So we have the entire call audio as well as we've transcribed it. But fundamentally, we know exactly what they're doing because we followed them step by step until the very end.
We've got Roebling in the chat room who makes a very good point. This is just a variation of the phone message you get. You just won a cruise. Call us back to find more details. That's essentially what this is, except, as you mentioned, it might be one of those three types of frauds. Either they're threatening you, they're telling you that there's a way out of the problem, or they're just informing you that you need to provide them with information. So, all right, there's going to be people who say, well, if you get scammed, you're stupid. It was your fault. I mean, I would have spotted the scam. Of course, I would have known that it was a scam. I wouldn't have done something so foolish. You get to see it at an entirely different level because you're not talking about one scam. You're talking about thousands, tens of thousands of scam attempts.
Yep.
Why, Vijay, is it so successful?
Okay, so in this particular case, right, what they did is they called and they refused to let our researcher ever keep the phone down. So they kept saying, you know what, if you hang up the phone, we can't say that you're any longer engaging with us, which means you're in violation of some IRS law, and therefore what you need to do, and then we'll have to send the police to you. So their entire mode of operation was to keep us on the phone, constantly keep telling us how dire the consequences would be. And then they, when we went driving to the ATM, they were with us. When we pulled the money out of the ATM, they were with us. When they instructed us to go to Walmart and get a MoneyGram, they were with us, right? They refused to ever let us go. And, even the way they do it is actually really interesting. So, if you take a MoneyGram, they were constantly asking us for information. So they asked us for SSN, all of those pieces of information. So they're not only doing this IRS scam, they're collecting a dossier of information on us through this entire call. But when we asked them for any information, they said, no, you don't need to know us. In fact, if you look at the MoneyGram scheme that they asked us to send it, all we had to do was give a first name, last name, and a city. And within 10 minutes, apparently, they get the amount, right? In our case, they were trying to get $1,900, but they were doing that. And so they were constantly pressurizing us, constantly using the threat of arrest as a way to get us to comply, and never getting off the phone. And, when they do this at such large scale, so even our honeypot has gotten 8,000 calls since Jan 1st, each of them, one of these guys trying to scam someone, right? And so we've gotten a lot of calls. We've analyzed those calls, but we managed to be on the receiving end of one of those calls with a researcher. And the kinds of things they said, the way they abused us, it was insane. In fact, if you go listen to that call, you actually feel bad for the researcher, knowing fully well that they know what they were getting themselves into.
Wait, do you have those calls online?
Yep, we can send them to you.
Okay, you know what? We can't do it for this episode, but please send them to me. We will have you back just to play those back, because that sounds like that's fun. That's an episode in and of itself.
And you probably have to censor some of it. It's really abusive.
We'll do a late night episode of TWiET, and it's the real deal. All right, so let's talk a little bit about something that's near and dear to my heart, and that is things that are fast. And right now, the thing that is fast that is getting the most attention is SSDs. They are making a huge push into the enterprise. In fact, we have a couple of our sponsors who have as an advertising bit the fact that they run all SSDs, or they run enterprise SSDs. What have you seen as the trend in SSD world? The last time you were on, we were talking about perhaps being on the cusp of switching SSDs with hard drives, where SSDs would now be the norm and hard drives are the add-on later on after the fact. Are we there yet? Are we headed there? Or do you see that in the near future?
I mean, I think it's just going to keep being a gradual thing, really. You'll have enterprises that, and I'm sure the other guys on the podcast can attest to this. You have your system. Everything is, qualified, certified. It's, ready for production or what have you. That thing you're kind of just going to leave there until you're about to end a life it and move to something else. And then, then the next time you do that, oh, okay, we should move to this SSD stuff. And sure, you're going to see a lot of that versus, oh, we're just replace this hard drive RAID with just yet another hard drive RAID, right? People are going to look at the results and just how much faster SSDs are on their next upgrade cycle, right? And it's just going to result in that transition, right? You're just going to see less hard drive sales, more SSD sales, at least for the things where, IOs per second is more important than just bulk mass storage, right?
Let's talk a little bit about that IOPS per second versus bulk storage. Now, I have one of the original NVMe pieces that I ever got my hands on. This was about a year ago. Kingston released this Predator. This is actually the card. This is the M.2 card. I do not believe this is one of their NVMe models, but it was a PCIe connection because they recognized most motherboards back then didn't have an M.2 slot. And this blew me away. The speed of this device was ridiculous. And then actually I have an M.2 enabled laptop now, and that combined with a large standard SATA SSD has been an absolute dream. But one of the markets that Kingston, that Intel, that Toshiba, that Micron have been aiming for has been the enterprise market. Can you explain again, because this is a good thing to remember, what's the difference between a consumer SSD like this and an enterprise SSD? Is it just semantics?
So in a lot of cases, physically, they're very similar. And in even more lots of cases, it might even be actually the same flash chips, maybe just binned a little bit differently, like just a little bit better grade of flash. They might be doing a little bit different things internally as far as how the controller is talking to that flash and what modes it's putting that flash in. But a lot of the times the controller is even the same, right? You have Intel, for example, their data center series PCIe NVMe SSDs versus Intel SSD 750 consumer parts. It's the same controller. It's pretty much the same flash. There might be just less provisioning of it, less extra flash compared to the capacity that's available. But the big, huge difference between those two things, enterprise and consumer, is down to firmware tuning. What that firmware is designed to be able to handle as far as a workload. And it really boils down to enterprise tends to go more for just like you have a database server or just something that's going to receive nothing but pure random writes, like 4K or 8K random for its entire life. Versus consumer, where most of those writes are probably going to be sequential. There might be a little kind of hot spot on that drive where Windows is keeping its registry and just other files that are being manipulated that look kind of like an enterprise workload, but it only is applied to just a very small slice of all of that space, because the rest of it is just, you have people's games sitting on there, their movies and whatnot. So what that enables the companies to do and have a difference between those two is that for the consumer side, there will be less what's called over provisioning. There'll be less extra flash. So when you're buying that part, you're not paying for as much raw flash memory to be installed on that compared to how much capacity you're getting that you can actually fill with bits. For the enterprise parts, though, to get those ratings, to be able to hit the flash that hard for that long, a lot of the time they will be over provisioned to a much greater degree. Right, there are Intel SSDs out there that have like 2 and 3 times the amount of flash on them compared to the available capacity, and that's just to be able to handle those much harsher workloads for the whole lifetime of the device.
That was one of the points that you brought up the last time you were on, and actually we heard that from the Dave, a representative from Kingston, when he came on, and that is, the parts, they go through the same manufacturing process. It's not like you have super flash that goes into the enterprise products and you have the regular flash that goes into Joe Schmo SSD. Most companies will use the same processes. They will just over provision for the enterprise product, thinking, okay, we're probably going to have double the amount of rated storage because this device needs to last a lot longer. But you mentioned this with the firmware, it's not just over provisioning, right? What are the things that you emphasize for enterprise operation that you don't necessarily need for consumer?
So to take just a note right out of Intel's testing playbook, because they actually kind of have one. If you're testing a consumer SSD, like when I test consumer SSDs, I will fill them sequentially with data to emulate just a person filling their SSD with, games and whatnot, just movies, just stuff sitting on your drive. But I will only randomly access an 8 gigabyte span. That's kind of like the industry accepted consumer SSD standard for like performance testing for consumer side. Enterprise, though, that testing, all bets are off. It's just the whole drive, random access across the entire thing continuously. And that just makes it a lot harder for the SSD to handle what's going on, right? Because there's tables inside the controller that have to maintain what bits am I putting in what sections of flash to try to optimize things and try to get extra life out of the flash and try to wear out that, level out that wear that occurs. And all those things have to happen on a full span versus just potentially a very small span for consumer, right? And nowadays, if you take a consumer optimized SSD, just a consumer version of an SSD that you know that there's an equivalent enterprise part, if you hit it with full span random access like that, it'll just come to its knees, basically. It'll look pretty bad.
Right.
9 times out of 10. And that's for good reason. It's because it's optimized on some assumptions that are more consumer driven. And if you with those SSDs nowadays, what will happen is if you do that kind of workload to it and it slows it down really bad, if you come across later and you sequentially write to it or you put normal files on it or you start behaving like a normal consumer would with it, it will speed back up. And that was actually one of those problems with the original X25M. That's what got me into the whole reviewing thing in the first place, right? I took a X25M, did some kind of sort of more enterprisey stuff with it, and that actually caused it to slow down and not be able to speed back up. And that's what got me into this whole thing.
A lot of people know what the internet is and have some idea how that works. But one of the things you don't really think about is some of the infrastructure behind the internet. In order for the internet to work, every device has to have a unique address. And that uniqueness has to happen somewhere. Now, we could have had the ISPs. The first ISP chooses any number he wants. The second ISP calls the first one and says, what are you using? I'll use some others. The third one calls the first two. By the time you get up to the 50th ISP, he has to call the other 49 to see what's in use. It doesn't scale. In order to make it a scalable process, when the internet was getting going, they established a formal registry of internet numbers, IP addresses, as everyone calls it, so that when someone new was connecting to the internet, they could connect to the internet and get IP addresses that they knew were unique without having to pick up the phone and call everyone else already on the internet. So that registry function, what we call the Internet Numbers Registry System, is actually distributed around the globe in 5 regional organizations. One of those organizations is the American Registry for Internet Numbers. We handle Canada, United States, and about half of the Caribbean. And we're the ones that internet service providers, large corporations, ISPs, wireless ISPs, small enterprises come to get their own unique IP address block so that when they connect to the internet, their computers have unique numbers and no one else gets in their way.
Right. And exactly. Aaron is the body that allows us to do all of that without having to worry about every time we type in an address, every time we type in a number. Now, let's back up a little bit because I can think 2 decades back, and I was starting to get notices of IP exhaustion. The IPv4 was running out of space. When they first envisioned the system, they thought that 32 bits was going to be plenty. You'd be able to give every computer an IP address, but of course then there was the IT explosion, and we started running out. But then we created NAT, Network Address Translation, which allowed us to sort of give longer legs to IPv4, but that didn't kill the problem. It just sort of kicked the can down the road. There was a solution for IPv4 address exhaustion way back when I first heard about it, and that was IPv6. But is the IPv6 I heard about when I was a young admin the same as the IPv6 that is being pushed today?
It actually is. The history of this is interesting. Back in the early 90s, the IETF, the Internet Engineering Task Force, which does the internet protocols that make the internet work, a number of us at the IETF realized that the growth of the internet at that point was so fast that IP version 4, the protocol that's used to connect the internet, wasn't going to last long enough. And so we had to do something about that. We actually did 2 things. we were giving out address blocks in classful state. I think people might remember this. Class A, Class B, Class C, a address block that might be 16 million addresses or 64,000, or the smallest one, a Class C, is 256 addresses. If someone needed 1,000 addresses, you couldn't give them 4 Class Cs. You had to give them a Class B. You had to give them effectively 64,000 addresses, even though they only needed 1,000. So the first thing we changed is we made the internet variable. We introduced classless interdomain routing, CIDR, a notation that network engineers know as slash notation, the ability to say a network address and how many bits are significant. That let us refine our issuance of address blocks so that we weren't giving them out as fast. But even then, we still knew the internet was going to run out of address space. And we knew it was going to happen around 2015 to 2017. So back in the early 90s, we created the IP Next Generation project, and that became what you know as IPv6 today. There have been some things. We thought IPv6 would be popular, but ultimately it solves one problem. It solves running out of IPv4 addresses. And that problem really hasn't happened until last year. Last year in the American region, in September 2015, in Aaron's region, we ran out of IPv4 addresses. So IPv6 is now taking off dramatically.
Right. I'm thinking back to Interop. We when I was still working with the Interop conference, we actually had an entire Class A, and I think we had 4 Class Bs, and then at least 24 Class Cs. So those were the heydays, the halcyon days, where the Interop team members, we would borrow like Class B for a while, just so that we could spool up a bunch of devices. I think we actually gave most of those back. I think we kept a couple of Class Cs for ourselves, but we were good citizens, and we answered Aaron's call. Aaron said, look, if you're not using the addresses, you should really return them to the pool. That was the agreement. Interop, we did that. Has everyone been a good internet citizen in that respect?
Remarkably so. So 2 things to think about. First, even though we did IP version 6 2 decades ago, it was became a production, an internet draft standard, and then a final standard in 1997. And people say, well, if it hasn't been deployed, obviously it's a failure. It did get deployed. It got deployed where it had to be deployed. It got deployed into the operating systems, like your Linux and your Mac OS and your Windows all support it. It got deployed in the backbone routers. Routers from major vendors, Cisco, Juniper, all ended up supporting v6 a decade before anyone needed it. We had to do IPv6 and get it standardized so long ago, so it would already be installed in all your equipment, ready to turn on when it actually was needed. That's why we were doing it 2 decades ago. But the other thing to think about is that when we got close to the end, and in the Aaron region, that's been over the last 5 years, we've been slowly running out. A number of organizations that had large address blocks that didn't need them, including the folks at Interop, the folks at the Department of Defense, my alma mater, BBN, Bolt, Brennick, and Newman, the original operator of the ARPANET, Stanford University, all returned address space so that we could continue to issue IPv4 to customers, and that's how we got as far as we did. But there's only so far you can make IPv4 last. IP version 4 only goes, at the end of the day, it's only 32 bits, so it only goes to 4 billion devices. 4 billion devices isn't enough to let everyone on the planet have one cell phone, let alone every server, let alone your home computers, everything else. So we knew v4, no matter what we do, wasn't going to cut it. And IPv6 actually is taking off remarkably fast.
Yes, I mean, all of our devices. If you've bought a device, okay, let me say this. Unless you're using an antique device, it most likely supports dual stacking. So it's got IPv6 and IPv4 built in out of the box. But there would be people who say, yes, it has IPv6, but I would never want to turn off IPv4. From your perspective, does Aaron keep track of how much of the IPv4 space is actually being used versus allocated? Because there are, I mean, if you look at the IPv4 map, there are still some sort of legacy handouts of IPv4 addressing space that you can almost guarantee is not being used even 10, 20%?
So a couple of things to think about. First, it's important to remember it's the public internet that's going IPv6. It's not everywhere. You have a printer under your desk that speaks IP version 4. Let it speak IP version 4. You don't need to switch. But the public internet doesn't have a choice because the number of new devices, mobile devices, tablets, all getting connected requires IPv6. If you look at what the mobile devices, a lot of people run IPv6 on their smartphone. They don't even know it because their major carrier, AT&T, Verizon, T-Mobile, have switched to using V6 already. So the public internet doesn't get a choice. That doesn't mean enterprise needs to change its internal network. You can go do a stack on your network. But the main thing is to think about your public-facing website, because more and more devices are going to be trying to access your website over IPv6. And if you don't support it, then you're going to have a problem. Regarding those old IPv4 legacy addresses, we actually did establish a market so that organizations that got IPv4, got a huge block, don't need the whole thing, can transfer the unused addresses to someone who does. So if you're a community college and you received a huge address block, it might take you a lot of work to renumber and get out of that block because you're only using 5% of it. You can get paid for the address block so that you can do the renumbering. That's part of the market we set up. And that's also a good thing for enterprises and large ISPs who need a little more time. They can probably go to the market and get 1 or 2 more address blocks, but we know that won't last forever.
We have our 3 experts. We're going to do a little bit of a round robin for the first round of questions because we want to talk to you, the 3 of you, about the challenges of deploying high-density wireless in large venues. Heather, let's go ahead and start with you since we started with your introduction. What would you say would be the greatest challenge of deploying in something like a conference center or a stadium where you have a lot of mobile devices all wanting access to the Wi-Fi, all from different manufacturers with slightly different flavors? What's the #1 thing that a Wi-Fi engineer needs to be aware of?
You mean what are the top 5 things that you need to be aware of?
Let's do that. That's even better. You're making more work for yourself, Heather.
So you sort of hit the nail on the head about the first thing. So we've got mobile devices, and in venues like this, you're seeing at least 80% mobile device, rather, depending on the conference. But really, I think the biggest problem is there's no such thing as a cookie cutter. There's no template where you can just sort of like, oh, well, I've been there, I've done that, I know roughly what I'm going to do. Let's say, let's take a generic venue, like say a stadium of some kind. What's going on there today? What are you designing the network for today? Because tomorrow it's going to be completely different. And it's not just what the users bring in to use, it's who are they? Are they 16-year-olds that are looking for Pokemon? Or are they 50-year-olds that are just now sort of figured out how to FaceTime? And so the oversubscription rate that you can assume and the uptake rate for those clients varies greatly. It varies greatly even within a keynote address. I watched traffic just spike. It depends on who's in the audience, but it also depends who's up on stage. If it's a bit of a snorer, then up on stage, then all of a sudden the data usage on the mobile devices goes way up because everybody's...
I never even could... That is perfect, actually. I should have been watching that during the interop keynotes. Yeah, if you start to see more data being drawn by the APs, it means they're bored and they're now looking for something to occupy their time. That's a big data correlation. Well, thank you.
And I was sitting in the keynote, and I was grateful for the interesting people who were speaking because it kept my people a little quiet and placated.
Actually, I do want to go over to Rick for something because you did mention that you have to be aware of your audience. Are they 40-some professionals? Are they 16-year-olds looking for Pokemon? But Rick, there is another aspect to this idea of deploying, especially in a temporary area like a convention center or a semi-temporary area like a stadium. And that is security can no longer be an afterthought. I mean, yes, you want to make sure that you can get Wi-Fi access throughout the venue, but at the same time, you also need to make sure that your equipment is secured. You need to make sure that you're locked down for authentication and your portal. What's the work that you've done as far as pen testing, and how does that inform how I might design my convention center wireless network?
You bring up a very interesting point. You need to design for security in the first place. And in my experience going to multiple industry conferences and hacker conferences and whatnot, that doesn't happen ever. At best, security is an afterthought, and it's normally a very poorly thought out one. So my team got bored the last couple of 4 years at DEF CON and took over the DEF CON secured wireless and grabbed everybody's username and password. And that's it, the biggest hacker conference in the world, set up to deflect the biggest hackers in the world, and still just security was totally an afterthought, and a lot of that's just not well thought through. You hit the nail on the head when you said we should think about this first. The problem is people absolutely don't. There's a lot of really easy stuff that even mobile devices support these days that is just plain left off. 802.11w that completely blocks deauthenticate attacks. 802.11r that will rapid roam and not try to reauthenticate constantly, which is a big source of slowdown when moving from AP to AP. These are things that all of your basic mobile devices actually support just fine, and we don't ever turn them on.
Actually, we lost your audio just for just a bit there. Which DEF CON was that, by the way?
Let's see. 17, 18, 19, 20.
Wow. Okay.
22, 23.
Okay, so
we skipped one.
Because I remember 2 years ago they moved to you had to get a certificate ahead of time so that you could get into the network, and I was looking at it going, I don't think this is actually going to help, and thank you for confirming that.
Yeah, that's pretty much when we thought it was really, really funny and started doing it much bigger, larger antennas and whatnot.
See, I think that's actually the worst of the worst, because when you start doing something like pre-authenticated certificates, you do lull people into a sense of security. They think, oh, now it's okay. I can go ahead and use the wireless. But, of course, we have people like you who just sort of point and laugh.
Yeah, we had a nice conversation leading up to this that I'm not going to out anybody, but a lot of people were given really good advice like, oh, I'm going to Black Hat and DEF CON and I'm leaving all of my gear that I care about at home, or I'm going to bring a brand new netbook and I'm going to blow it up later. But yeah, the false insecurity thing is a really big problem, especially when you have, a bunch of signs that say WPA passphrase this, and people are like, oh, great, it's secure. But if you have the passphrase, you can decrypt every single packet. So realistically, that's exactly equivalent to running an unencrypted network.
My favorite was it 2 years ago? They had posters that had little NFC stickers here, and it said, tap here to get a freebie. And I'm thinking, would anyone actually do that at DEF CON? And I saw at least 3 or 4 people go up there and tap their phones to it. I'm thinking, okay, no, this will not stand. All right, we'll come back to DEF CON because it is fun. And it is coming up, so it's going to be a party. But let's get over to Christopher. Christopher, you work with NetScout. We've been talking about some of the initial considerations that you must make when you deploy a wireless system. So Heather was talking about making sure that you can collect metrics, making sure that you look at the audience that will be using the wireless. We had Rick talk about security and making sure that security is a forethought and not an afterthought in your deployment. From the NetScout point of view and all the tools that you provide, how do you properly collect metrics from a wireless system?
Well, I think Heather really hit on it. The key thing that you need to do is have a plan going in. If you have a plan, you can sit down with some form of planning software and actually lay out the network to achieve what you want to achieve. But to do that, as you said, you have to think through what sort of client devices you're going to be servicing, what they're going to need. She made an excellent point about, knowing who your client base is. Are these guys looking for Pokemon? Are they going to be downloading programs? Are they going to be streaming video? That all has a huge impact on the way you plan. And then you go ahead and model that. The thing that a lot of people also miss is they come up with this great plan and they assume it's all going to work out. But let's be honest, the guy who does that plan is not the guy who's going to climb up to the ceiling hanging cables and placing APs. So they just assume that that guy's going to follow whatever they set up. And a lot of times that person doesn't, because oftentimes the guy on the ladder has no idea what an access point is.
Right.
And he doesn't really know how to orient an antenna. He doesn't know why it's important. He knows that it's not supposed to look ugly, so he tucks it behind that nice metal girder. And then, gosh, I don't know why the Wi-Fi is not working. And so the thing we see people miss a lot is after they've done all this great planning, get out there and actually validate that it got installed the way you expected it to be. Because if it didn't get installed right, if somebody did something you weren't expecting, put the antenna on wrong, et cetera, you're going to have massive problems, and you're not going to be able to figure out why. Another aspect of what I think Rick was talking about that's important for people to think about is that security has to be thought about up front, but while an event is going on as well, you need some ability to troubleshoot and get out there, get visibility so that you can sense what's going on. And sometimes, something like DEF CON, you've got a lot going on. But even in just a convention space like what Heather was talking about earlier, where maybe there's one bad guy or maybe even there's none, there can be well-intentioned people who come in and are causing security holes for you or putting in extra things, what is, in your opinion, a rogue AP that's going to cause issues long-term. So you also need some kind of troubleshooting or on-the-fly tools that you can walk around with quickly, easily, and get insight into what's going on. And so we really look at it almost like a life cycle. I've got to have pieces and tools throughout all the different steps that I need to take to make sure my event or my stadium or my large venue goes off without a hitch.
Actually, Chris, that's brilliant. Thank you very much. That point about the people up on the ladders are not the engineers. We hit that all the time at Interop, especially when you're deploying in a venue. You don't have the ability to send your engineers up on the ladder. You have to use the union folk, and the union folk are not trained Wi-Fi engineers, so they will do silly things like putting it behind steel girders or orienting it the wrong way. Open question to the three of you. What has been the worst deployment you've ever seen of an AP in a large venue?
I have two worst ones.
Heather, we'll go with you first.
And I got to give a shout out to Twitter's Hey Eddie, because he has the BadFi website where people send him pictures of the best of the worst deployments. And if you just want to spew your coffee one morning, that's a great place to just cast your eye on. And this is great because both of these were ABC competitors of other Wi-Fi vendors. One was literally company C's access point sitting on top of company A's location-based access point, and then encased in a steel girder, a steel cage. I mean, it was like they went out of their way to make sure that this was going to be almost, but not quite, completely unusable, and it was. Okay, that's pretty good. So Wi-Fi sandwich inside of a steel cage. That's hard to beat. Rick, you look like you had one. Do you have one that could top that?
More going back to the statement that was said before of people always install APs very badly, especially going back to the era of nice big metal access points, especially ones with like 2 antennas on them. I saw a convention where they were instructed to install them as close to the ceiling as possible. So they mounted the access point and then they folded the antennas down onto the metal box and they put that up against the ceiling tiles. So that way it was as far out of the way as possible, and they literally blocked their own signal with the access point. Which
Not bad. Okay. Christopher, I want to throw it to you in case you've got one.
Sure. My favorite for just making me laugh, and again, the credit definitely goes to BadFi because this is where this one came from, was, and I don't know what the person was thinking. I don't know why. There was a big screen TV that was mounted to the wall. They had decided that the right place to put this AP was to kind of tuck it propped up against the back of the TV, but not mounted in any way, just sort of set in there, because why would you put a screw in the wall when you can just kind of shove it on in there and assume it'll be fine? But somehow or another, a bird had found this particular location, had built its nest in the little crook that the AP and the TV made. So you had all these sticks and twigs and a little bird peeking out of this picture staring at you. That one just always made me laugh every time I looked at that, and especially because one time when I saw him presenting it, he had a little arrow to it, said, "It's a freaking bird." So that one always makes me laugh.
That sounds almost like some sort of art display, Wi-Fi with Nest. Who knows?
Well, if you think about when you're walking around every day, you see digital signs. So it's TVs, if you will, or monitors outside the home. And what we make is the equipment that bring those to life. So you see it every day. Sometimes you don't realize it, but every retail establishment, almost every fast food restaurant, all have some kind of TV displaying information. And that's what we do. We do it in retail. We do it pretty much everywhere. And it can be everything from architectural type signage to, cool art, to digital menu boards, to promotional items, you name it. We bring the TVs outside the home to life.
Now, there's going to be people who are wondering, okay, that sounds cool. I mean, yeah, of course, I've seen digital signage. It's the new thing. I'm walking through an airport. I'm walking through a mall. I'm at a restaurant. I'm driving down the freeway. I know what digital signage is. But what's the challenge of digital signage? Why is there a company that specializes in this? Isn't it just me hooking up a computer to a screen and letting it go?
Well, that's where it all started. I mean, people would take just normal computers, hook them up to screens, and then you get disaster effects with that. You see the Windows blue screen of death on a 50-foot billboard. You walk up to a cafe where they're using digital menu boards, and it's all black. It's like, what are we going to do? We have no way of displaying our menu. So what we do is basically take what would typically be a computer and make it an appliance. And I always joke with people, it's like you can have a general purpose thing or you can have a specific device for the job. And you walk into everyone's kitchen and they have a big oven. And that oven, it does a lot of things, including toasting bread. But then I look around in their kitchen and they've got a toaster. Why do you have two devices doing the same thing? Because that oven is a horrible device for toasting bread. And the toaster toasts bread really well.
Absolutely. Now, tell me a little bit about what you had to do to make a device that could do this well. I mean, yes, we know we're past that first generation where it was just anything that could display something became digital signage. If you want to do it professionally, what are the challenges you're going to have to overcome? I mean, what are the things I'm not thinking about if I think I want to put a 40-inch display in a public area?
There's a lot of things that come up into it. The first thing is brightness. Most people, if you take like a TV that you put in your living room, it doesn't have very much brightness to it. It'll typically have around 300, 350 nits, which is the amount of brightness that it generates. If you put that in a retail establishment with bright lights, it'll look super dim. It'll be very disappointing, and quite frankly, no one will look at it. So one of the things is buying a monitor that's going to be bright enough. Second is buying a device, a computer that's meant to run 24 hours a day, 7 days a week, because most of these devices are left on all the time. And if you look at a normal computer or any kind of small device, those things are just not meant to be running 24 hours, 7 days a week. And the power supplies overheat, the electrolyte capacitors in the power supplies go out and they die, and then you get these black screens. And then the last thing is the software. I mean, if you put a PC in there, it's got Windows or it's a Mac, what do those things want? They want to do updates. They want someone to interact with them. PCs love to have people play with them. Our devices, they're built so that only when they want someone to have input or to interact with them do they need that input. Otherwise, they fix themselves. If something goes wrong with the media, they can completely recover themselves all over the internet. And those are the kind of things that you build into a device that's kind of commercial grade versus consumer grade.
Can you tell us a little bit about Kubernetes and how it compares to traditional containers?
Sure. Kubernetes is a management system for containers. It is not a container itself. So we use systems like Docker to run your applications in a cluster of nodes, VMs or physical machines, and we manage them based on the resources that you want to consume and the resources that are available. We figure out where to put them. We keep them alive. We manage them at a network level. We do load balancing and service discovery and all the things that you need to build a distributed application today. It's a distributed application toolkit, really.
And customers typically look to containers when they want to increase developer productivity. They want to make sure that developers can launch applications very quickly and iterate on them. And also, containers are a popular choice when customers want to move to a cloud-like architecture, whether it's a private cloud on their own premise or they're trying to use a public cloud with a vendor like Google.
Got it. So I hate to bring that word up, and I'll say it lightly, the DevOps word. I know I'm personally have had to deal with DevOps in the past, and it's not an easy thing to do. So can you guys maybe compare a little bit how Kubernetes compares to some of the other orchestration systems like Mesospheres or Mesos and Docker Swarm?
Sure. Mesos is a system that focuses on resource management, first and foremost. It carves your cluster up into pools of resources that you then offer to a second level scheduling framework. And Mesos supports a wide variety of frameworks that you can use to run workloads in your Mesos cluster. Compared also to Kubernetes, Kubernetes is a little bit more app-centric, a little less infrastructure-centric. We really want to focus on what application developers are doing and want to do with the system. Kubernetes is a one-level scheduling system. We don't have this two-level system. Comparing it to other systems like Docker Swarm, Swarm is actually a very similar system to Kubernetes in a lot of concepts. So, it's actually sort of hard to draw some comparisons there. Kubernetes draws on the Google experience. Docker draws on what Docker thinks the user experience should be from the Docker perspective.
Yeah, Kubernetes is architected from the ground up for container orchestration, as opposed to VM management or management of any other type of resource. It's really container specific. And it came out of Tim's experience and the co-founders here from the Borg team at Google, who wanted to take that expertise and make it available to the rest of the world. So it's very container centric.
Got it. So yeah, Google's just coming off their big conference here, and they've announced a whole lot of changes on the container management and orchestration, and to make it a whole lot easier. What is Kubernetes' position in the world of virtualization, and what actually got announced?
Yesterday, we announced, among other things, we announced the Kubernetes 1.4 release and its availability in Google Container Engine. Kubernetes is an open source project, first and foremost. So we announced the 1.4.0 release of that, which means it's available for anybody in the world to use. This is the result of several months of work by hundreds and hundreds of developers around the world. So a pretty incredible release, a ton of really great features. And then we are also launching 1.4.0 on Google Container Engine, which is our hosted version of Kubernetes. So that's generally available today.
Fantastic. So the Kubernetes webpage talks a little bit about planet scale. Can you tell me a little bit about that, and what do you mean by that?
Sure. I think that one of the best examples of what we mean by planet scale is Pokemon Go, which is a game that is played around the world and is actually hosted on Google Container Engine, which runs Kubernetes. And so that's what we really mean by planet scale, is users all over the world, and an application, a game being able to scale to meet the demands of a game like that's a augmented reality type game of the nature of Pokemon Go. That's one example of planet scale.
Well, I've been dealing with a lot of virtualization at the University of Hawaii, and when you start dealing with load balancing, that's like, oh, I'm going to have to buy an F5 or a Coyote Systems load balancer. But from digging around your load your web page, it sounds like there's built-in load balancing, and that's got to make the enterprise customers really, really interested. Could you tell me a little bit more about that?
Sure. So load balancing is such a fundamental part of this sort of third generation cloud native operation, right? Nothing is a singleton anywhere. And so when we built Kubernetes, we figured we had to go out the door with load balancing. It's a requirement. So we built into the system, first of all, an abstraction of services which have IP addresses and ports and everything you expect from a network service. And then you can implement that abstraction however your network environment sees fit. And along with the distribution of the system, we ship a couple of default implementations of load balancing so that even if you don't have an F5, if you don't have a cloud load balancer, you still have a form of load balancing that works. It's client-side load balancing, so you get sort of a very distributed decision-making, so you spread the load across your cluster, and your applications don't see it. It's really transparent to your system, to your applications. It's part of the Kubernetes system.
Yeah, and if a customer chooses to go with Google Cloud Platform has Google Cloud Load Balancing, which is global in nature, and that is, for example, what Pokemon uses.
Hi, this is Kurt. I've got a question really from the enterprise side of thing, and especially when you're talking about the global load balancing. We've seen a lot lately about the rise of hybrid clouds. Now, is Kubernetes designed specifically for the hybrid situation, or is it going to work best when you're dealing with one particular type of cloud at a time?
It's absolutely designed for hybrid. We're not tied to any one cloud provider. We're actually pretty fanatical about making sure that our abstractions are portable and work across different cloud providers. That includes your on-premise data centers. So everything that we've built for Google Cloud, for example, or for Amazon, you can also build for your own environment. Right now, a lot of enterprise stuff is very customized and very specific to your own installation. So it might need a little bit of work from you, the cluster administrators, when you're setting up a Kubernetes cluster, but you can implement all the same stuff that we implemented for Google Cloud very easily through our Kubernetes API, which is a very declarative, straightforward API to use. You can then take your applications and you can port them across these different cloud environments, run some on your premise, run some in Amazon, run some in Google, and it all just works, right? To a first degree, everything is portable. And this was completely on purpose. We did this, from the very beginning. We knew that hybrid was going to be an important part of the next 10 years of the industry as people shift from on-premise into the cloud.
Yeah, and I would add that Kubernetes 1.4, the release that we just put out this week, adds quite a bit of support for hybrid workloads. And we've been doing that consistently over the past year. So for example, we've made it much easier to install a Kubernetes cluster anywhere, whether it's in AWS or it's on-premise. In just 2 commands, you can start the master and add nodes to it, and it's so much easier to start a cluster. Secondly, we've added a number of features around the umbrella term cluster federation, which allows you to manage clusters that may be in different clouds. So you may have a cluster on-premise, you may have another one in Google and another one in AWS. And with a federation control plane, it's a separate control plane, you can actually have a service that deploys to all of those separate clusters. You can also manage replica sets across those clusters, and a number of the other objects, fundamental objects in Kubernetes, are now available through this federation API.
Talk to me a little bit about why the people who are watching TWiET should care about the Brexit. I mean, is this really something that is going to have a significant impact on the world of IT?
It absolutely will. And in fact, you made reference in your earlier piece about the future and the forecast of IT spending, with a particular note on the impact of Brexit. A lot of the discussion on Brexit, certainly in the political sector, has been around the importance of a large European and global economy separating itself from one of the largest trading blocs. And that's been quite significant, in addition to the Prime Minister of the UK subsequently resigning as a result of this surprising vote. The vote was, just to put it in context as we start talking about timing, on June 23rd. So it's been just about 4 months since that vote took place. The part of that Brexit decision that's gotten a little bit less attention is the importance and impact of data sovereignty, which is something of very high importance within the EU and subsequently the former EU. And for those of your listeners who aren't familiar with it, data sovereignty speaks to the fact that in many countries, data which belongs in those countries, meaning the companies or consumers whose data is being managed, must remain in those particular countries. In the context of the EU as a single bloc, that has not been a problem because the EU was covered by the same data sovereignty law. However, once the UK separates from the EU, the question arises of where data should reside. How does UK data continue to live only in the UK as opposed to living in Frankfurt or Rome or Paris or Amsterdam? And conversely, how does European data, continental data, avoid traveling over the channel into the UK. And given the particular importance of the UK as a major European and, of course, international financial center, the question of data sovereignty and how that data will be segregated over the next few years becomes paramount to anybody involved in the IT community.
I mean, Esri is really an amazing company that many of you may not have heard about, but just really quickly, the company was founded about 50 years ago by Jack and Laura Dangermond. And at the time, they thought that geography and maps could make a difference in the world. That was their vision and their mission. And that has remained a consistent vision across, all the years that Esri has been doing business. And I think the most amazing thing of this is that if you think about the world right now, it's not less relevant, it's even more relevant than it has ever before. I mean, almost everything we do and we touch in life has something to do with location, and people want to do something with that location. So it really is kind of the core to our thinking and what we're delivering. So with that, one of the flagship product that we have, it's called ArcGIS. And if I want to explain it in 2 sentences, it really is a geospatial platform that basically meshes up 2 things, maps and data. And then you use spatial analysis to discover all kinds of different patterns or even hidden patterns to make smarter decisions.
Right, and this is all part of the big data movement. Now, when we think of big data, most of us are thinking of data sets that we get from sensors or from tools that we have within our networks, from analytic metrics that we might be collecting. Maps, GIS, Geographical Information Systems, aren't typically included in that. That's not at the forefront of our mind. Why should it be? Why, if I'm developing a new application, a new service for my company that's supposed to provide business intelligence, what does including a decent GIS source of information do for the overall analysis?
That's a very good question. And actually, we are in the middle of everything to do with big data and Internet of Things and all kinds of sensor networks. And, if you think about it, all of these, as I mentioned before, every data element coming from a sensor has a location and has probably a time element that people want to use to analyze further. So we have a great way to visualize, for example, very large amounts of data that's coming in at very fast speeds, and then get immediate visibility of what it means. Think about, for example, getting information feeds from social networks, and you want to be able, during, for example, an election cycle, to figure out what is mostly talked about, what are the hashtags that are used the most. You can immediately see that on a map where the hotspots are or the concentrations are of that kind of conversation. So we are already used and increasingly to be used even more in any of these kind of combinations. And this is not limited to any, we work with essentially all kinds of sensors that are out there. It's not limited to social networks. That can be, stream gauges. This can be things that we use to make cities smarter, right? We can get all kinds of information about traffic situations, traffic conditions, and analyze that to make a city smarter and react in the right way.
So we have Scott Ball. He is a product manager over at Esri. We'll see his video in just a bit, but for now, he's going to show us an actual example of how GIS and BI come together to give us something that is worth our attention. Scott?
Hey, thanks, Father. Thanks for having us on. I really appreciate it. So what I'm going to show you today is I'm going to give you a tour of a brand new product that we've made in conjunction with Microsoft called ArcGIS Maps for Power BI. You've been talking about big data, and this is one way that we're working with a partner and integrating into a BI system to help you do more, better things. So our map visual inside Power BI that we've just developed can help you with some common problems. And I'm going to focus on 3 main things when I talk to you today. First, I'm going to talk about how data can be misleading if you don't have the right tools. Second, I'm going to talk about how you can fill your knowledge gaps by adding spatial context. And third, I want to tell you how you can use maps to tell the best possible story with your data. So I'm going to start by looking at an election map. We've been seeing this thing over and over for the last few weeks, right? This is an example of how data can be misleading. It's not wrong per se, the red team won all the red counties and the blue team won all the blue counties. But it feels like an overwhelming amount of red, right? What this map doesn't take into account is population. So let's take a look at a map that does take into account population.
Oh, geez.
So when you have the ability to view two of these variables at once, in this case population, which I have a population field in my data set, and I dragged it into our size field well. And when I did that, that resized all of the counties as points. And so the small points show us counties where there are low population, and the big points show us counties where there's high population. And when you combine that, in addition to the variable of who won the county, which I dragged from my field picker over here into my color field well, that tells me red or blue, which one won. And so that tells us really quickly the size and the winner of each one of the counties in the U.S.
So this is done all automatically. You just drop the filter on it and it will redo the map for you?
It will.
Oh, I love
and you
that.
have some fine-grained control, and you can do more things with it. But yes, it does it automatically. And so I want to say, I don't think people were willfully misrepresenting the election. They simply didn't have access to tools that would do this for them. It couldn't do these two variable maps. It's really easy to do one variable maps. And now they do. They have access to this because this is a free add-in inside Power BI, or a free visual inside Power BI. And now that we allow bivariate mapping, these ArcGIS maps can help you make more accurate, more meaningful maps.
Folks, I just want to thank you all for being part of the TWiET Riot. It's been an incredible year. In fact, it's been an incredible 4 years, going on 5 years of doing this show for the TWiT TV network, and we wouldn't have been able to do it without you. Each and every single one of you who comes back every week to download our episodes, to watch live, to comment in our chat rooms, it means so much to us. The fact that we get to do something that we love and make a decent living at it means that, well, the TWiET Riot is for real. Now, we do want you to subscribe. In fact, we want you to spread the word about TWiET because we want to make this show even bigger in the new year. Just go to our show page at twit.tv/TWiET. There you'll find all of our back episodes, so you could perhaps send a few to a friend that might be interested in enterprise technology. Have him or her subscribe to our feed so they can get the audio version, the video version, or the high-def video version in their device of choice. Again, it's all because we love you. We'll see you in the new year with plenty new stories from the world of enterprise technology. Until then, I'm Father Robert Ballecer, the Digital Jesuit, just reminding you that if you want to know what's going on in the enterprise, just keep TWiET. Happy New Year.